recording. Okay, in this video we're going to go over the Chapter 4, Section 6 notes on properties of natural log functions. So the first thing you want to know is you want to commit these properties to memory. Okay, so every multiplication is an addition, every division is a subtraction. The power property allows you to bring the power in front. Okay, but look at this. If you have this, that is not equivalent to the natural log of m plus the natural log of n. You cannot distribute natural log. Okay, similarly, you cannot distribute natural log this way either. So these are no-nos. Recognize the difference between this right here and the product property, and this right here and the quotient property. Okay, so now let's start working on some of the problems. So it says, now thinking about these properties, can you explain why the natural log of 1 over x equals negative natural log of x? Well, let's see. That is a division, so I can change that to natural log of 1 minus natural log of x. Natural log of 1 is 0, so that's why this equals negative natural log of x. Okay, let's go on to the next page. So we're looking at a now. So can we write this expression right here as a single logarithm? Well, every addition is a multiplication. Okay, so first I would write down natural log. Then I would say I have the power property can be undone. So that's going to be 7 times 4 squared. And then I can do that math inside the parens and get natural log of 112. Okay, so we have a couple of things going on for number 2. This is the power to everything, to the 3 and the t. And then we have a subtraction. So that's going to end up being the natural log of, I'm going to just put this under a radical just to be safe, to make sure I distribute it to both the 3 and the t. And then my division down here is t cubed plus 4, and we're done. Okay, look at the next one. You've got a lot of things going on. Here's a power property that goes to both the 3 and the x. And then we have a division here. So write natural log, and then I have x times, why don't we just go ahead and say 9x squared. We have a y, and then all over 7. Then I would just clean this up. So I have natural log 9x, bring those together, cubed, y over 7, and we are good to go. Okay, we're going on to the next page. Okay, on this page I have a lot of practice. Now normally we would do this in class, but instead I've incorporated it into this video. So if you're asked to simplify the following expressions, number 1 should be natural log of 5x, and if you have to stop and kind of think about these things, that's not a bad idea. This is natural log, I have x to the 5th over x cubed, which can make that natural log of x squared, which can simplify to 2 natural log of x. Again, I may be going too fast for you, so just slow down and do it at your own pace and then check what I've done. Okay, so this is natural log of 9 to the 1/2 power. So that's going to end up being the natural log of just positive 3. Okay, so this is natural log, and I'm going to take 1/2 and raise that to the 3rd power and multiply that by 16. Now I start playing around a little bit. Okay, so this is really 1 over 8 times 16. So that's going to be just the natural log of 2 once I reduce everything. Okay, here we have natural log of 24 over 12, which is also going to be the natural log of 2. And now we have natural log of 2 times the 3, which is 6 on top, and an x in the bottom. And I'm going to leave it like that. Okay, so this next one, number 7, is kind of interesting because if I first rewrite this as e to the natural log of x squared, that will simplify to just x squared, and I am done. Whenever you have these next to each other, they kind of cancel in some form, and you just get whatever's left. And perhaps I should take a moment to explain this. So if you have e raised to the natural log of x squared, and let's just say we set this equal to y, because I want to figure out how to simplify this. Well, I'm going to now write it in natural log terms. So change the format. It's exponential right now. So logs equal exponents. So the natural log of y will equal the natural log of x squared. And therefore, for that to be true, y has to equal x squared. And that's how I got that. So once you get e raised to the natural log, you can simplify things very quickly. Okay, don't cross them out. Just recognize that this situation is playing in the background, which lets you simplify that expression to x squared. Okay, let's go over to number 8. So number 8, I have 4 raised to the 3/2 power divided by 2 raised to the 5th power, and all of that is behind natural log. So if you take 4 to the 1/2 power, that gives you 2. So can't I write this as 2 to the 3rd over 2 to the 5th then? And isn't that just natural log of 2 to the -2, which is just -2 natural log 2. Okay, so you can leave it like that. You can also view this as negative natural log 4, and I'm going to leave you to figure that out. Okay, let's go on to the next page and we'll finish up these practice problems. Okay, so number 9, looking at this, I see I have a power property here, another one here, and a third one here. Okay, so what I'm going to do is I'm going to say natural log, and then I'm going to take all my powers and bring them back up. And because you have no repeating variables, that's your final answer. Okay, so now look at this next one. Why don't we do this? This previously was a multiplication. What was it a multiplication of? It was a multiplication of this times the times e to the natural log of y cubed. So that's what it was in a prior life. Okay, so we know if I have this together, the first term simplifies to x squared, and if I have this together, the second term simplifies to y cubed. So that is the final answer there. Okay, let's go on to another one. Okay, put natural log. I have x times x to the 4th, so that's x to the 5th, over x squared. So that's natural log of x cubed, which we can turn into 3 natural log of x. Okay, last one, and I think it's probably the most complicated one. So what I'm seeing is I have natural log of, let's see how I did this. I first did this. I have this raised to the 1/2, and then I have times the y, let's see, times well, here, let me just restart this, so I'm not going to complicate things too much. I'm going to keep things simple. Okay, the first thing I did was I said natural log x to the 1/2 plus natural log of y to the 1/2 plus natural log of x to the 3/2 minus natural log of y to the 3/2. Then I said, okay, since we have all those additions are really multiplications. So now I'm going to bring all my multiplications together and then put my division in the bottom. And what's going to end up happening is, in the numerator, you are left with x squared, and in the denominator, you are just left with y. So make sure you can figure that out. There's a couple of ways to attack that problem. This seemed to make the most sense to me, so I just did it this way. Okay, so that's the end of the practice. Now let's finish the notes. We don't have much more to go. Okay, so in terms of notes, they're going to ask you in this section to evaluate expressions using an approximation. They want natural log to equal 0.69, and they want natural log of 3 to equal 1.1. So natural log of 2 is 0.69, natural log of 3 is 1.1. Okay, so that means if you're going to do this, you're going to need to break natural log of 6 up into components that are 2 and 3, which you can do. So natural log of 2 times 3, or natural log of 2 plus natural log of 3. So 0.69 plus 1.1, that gives me 1.79 for an answer. Okay, so natural log of 54. So think about that as natural log of 9 times 6, and that's going to be natural log of 3 squared plus natural log of 3 plus natural log of 2, and I can make that 2 times natural log of 3 plus natural log of 3 plus natural log of 2. So 2 times 1.1 plus 1.1 plus 0.69. 3.99 is my answer. So again, I'm probably going too quickly for you, so see if you can just stop the video, figure it out, and then check and see whether you're correct. Okay, so next type of problem, they're going to ask you to solve the given equation for x. So look, they've set things equal to 0. So what you're going to do is you're going to use your properties. So you're going to have natural log of x squared over 2x plus 1 is going to equal 0. So this is natural log of x over 2 plus 1 equals 0. So where can we go from there? So let's see what I did. What I did was, I said, okay, I'm going to move this 1 over as a -1. Then I'm going to change form. Okay, I find a lot of times changing form is the key. So this is in natural log form. Let's write it in base E form. So the base is E, logs equal exponents, so the exponent is -1, equals x over 2. So coming back up here, what does x equal? X equals 2 times e to the -1. Okay, sorry for cramming it in there. Okay, next one. So I'm looking at this and I'm seeing this is equivalent to natural log x cubed divided by 3x, and that has to equal 0. Okay, so there's a couple of ways you can attack this. What I did was I reduced this first to natural log of x squared over 3x, and then I said, over 3, sorry. So let's get rid of that x. Okay, so then I said, oh, that means that this is natural log of x squared minus natural log of 3. So therefore, the natural log of x squared has to equal the natural log of 3, and that means x squared has to be 3. Therefore, x equals, now let's think for a second. Could it be plus and minus radical 3? And the answer is no. So it's only going to be positive radical 3. Okay? All right, so now we're getting into calculus. All of this procedures we've done so far has just been pretty much algebraic manipulations. But here's a wonderful calculus problem. So they want us to differentiate using the properties of logs. Okay, so the first thing you're going to want to do is absolutely rewrite this using the properties of logs. That's going to be this plus this plus, do the power rule also, this. Okay, now you're ready to go. Y prime equals the derivative of natural log of x plus 2 is 1 over x plus 2 times the derivative of x plus 2, which is just 1, plus 3x minus 4 times the derivative of 3x minus 4, which is 3, and then plus x plus 7, the 2 comes along for the ride, times the derivative of x plus 7, which is 1. So taking away the extraneous or the extra 1's, this looks like this. Okay, and we've left the best for last, so the last page has one of my favorite calculus manipulations. So this is a great time saver, as I've said. Okay, I'm just going to get rid of this to give me some more room, because we know the homework already. It's on another handout. So, key thing is here, logarithmic differentiation. Notice I don't have any logs. You can take the log of both sides of this equation without violating any algebraic rules, because as long as you do the same thing to both sides, you are good to go. So let's start out doing that. And why don't I'm going to kind of combine steps to save me some writing here. As I'm taking the log, I'm using the properties as well. So this can become 3 times the natural log of x plus 7 plus 5 times the natural log of 4x plus 2 plus 2 times the natural log of x minus 2. Now, I haven't gone from bad to worse. I've made this much easier. Now we're going to take the derivative. So it's kind of like an implicit differentiation. You're going to take the derivative on both sides, and on the left side, you're not going to get y prime. You're going to get 1 over y times y prime. And just remember, our goal is to get y prime. So take the derivative of the first term. 3 comes along for the ride, over x plus 7 times the 1. That's the derivative of the x plus 7. I'm not going to write that. Plus 5 comes along for the ride. And then you have 4x plus 2 down here times the derivative of the 4x plus 2, which is 4. And then plus 2 comes along for the ride, x minus 2, and then times the derivative of x minus 2, which is just 1. Okay, now you are not done. Okay, let's change this, now that we've done it. Let's change this to 20 so that it looks nice and neat. And now our goal is still to get y prime, right? Not 1 over y times y prime. So what I'm going to do is I'm going to multiply both sides by y. But I can't have y in my answer, so I have to actually rewrite the whole expression for y. So I'm going to now use brackets. So I have what I first got by taking the derivative. Okay, so just copying this down. And now you have to copy down your entire y expression. So you have to use another box or another bracket or another parens, however you want to do it, as long as you know that you're multiplying both of these big components by each other. Done. Okay, so it's a messy answer, but you get to it very, very quickly. So, difference between logarithmic differentiation and using logs. When you have logarithmic differentiation, you do not have a log present in the original equation. So you have to introduce it by taking the natural log of both sides. Okay, if we go back, when we said differentiating using properties of log, notice that you had the natural log present. And so what you did was you just used the properties. You didn't have to introduce natural log. It was already there. So make sure you understand this distinction because that's the problem that I see a lot of students run into. They forget that they have to multiply by the original y to get the final answer because they introduced natural logs where they didn't have it. Okay? And that's the end of this video.